Hello students, today I have prepared an MCQ multiple choice questions for the topic IC engines, which is very important topic for competition exams, all government and private job competition exams, as well as helpful for interviews in automobile industries in case you are going to appear for interview in automobile industries. Then also these questions will be helpful. So I have developed more than 30 questions, approximately 60 questions, 60, 62. So in part A, I will speak 1 to 30, and then in next part 31 to further questions. Okay, so this is only revision short briefs I will present. Okay, and these are genuine questions. I have not used any AI, and you can do this activity. Okay, check yourself how much marks you are obtaining at the end. Now let's start. Following is an example of IC engine, internal combustion SI engine, that is spark ignition engine, CI engine, compression ignition engine, jet engine used in jet planes, all of the above. What is the correct answer? Internal combustion engine is what? In which the combustion takes place inside the engine itself, inside the engine system itself. Okay, it is not like that heat is developed outside and then it is transferred to the engine system. It is developed inside of the engine itself. So, what is the correct answer? The correct answer is all of the above. Okay, all these types of engine are actually internal combustion engine. Now, following is an example of EC engine, external combustion engine. Engine is a device, heat engine, in which heat converts into work or heat converts into mechanical energy. Okay, so there are two kinds of engine, IC engine and EC engine. IC internal combustion engine, EC external combustion engine. Okay, so steam power plant, closed loop gas turbine, locomotive engine, all of the. What is the correct answer? The correct answer is all of the above. In steam power plant, what happens? That is heat is developed outside the system, that is in the boiler. Okay, so coal is burned and heat is supplied to the working fluid like this. That is water. So ultimately, heat is converted into work. By the help of that work, electrical power is developed. Okay. Now, closed loop gas turbine. Remember this thing. There are two types of gas turbine: open loop and closed loop. So closed loop is the one in which the combustion doesn't take place inside the gas turbine system. The heat is developed outside and then supplied to the gas turbine. Locomotive engine is one which is used in train engine, old train engines, in which by the help of coal steam is developed and then by the help of that steam the wheel is made to run. Okay, so all these types of engines are example of external combustion engine because heat is developed outside and then supplied to the working fluid. What is the brake power of an engine? Brake power, the useful power available at the crankshaft of an engine. Okay, the heat power input to the engine, the power available over the piston crown while the heat transforms into work. Means when the fuel burns, then actually the heat energy converts into work on the piston crown first of all. Okay, so what is the correct answer? What is the brake power of an engine? The answer is the useful power available at the crankshaft of the engine. Means ultimately the power is available at the crankshaft, so that is called as brake power. Now, if P1 and P2 are the pressures before and after compression in SI engine, in compression stroke, before compression, after compression. So P1 is the initial pressure, P2 is the final pressure. What will be the efficiency expression in terms of pressure ratio? Means in case P2 by P1 I am taking as a pressure ratio RP. In terms of that, what will be the correct efficiency expression for the SI engine? What it will be? The correct answer is second one. 1 minus 1 by Rp raised to power gamma minus 1 upon gamma. Here gamma is the ratio of specific heat of the working fluid we are using. That is air. Normally we use air as a working fluid in the engines. Okay. So how this formula is derived? Simple. In terms of compression ratio, the SI engine efficiency expression is 1 minus 1 by Rk to the power gamma minus 1. Here Rk is the compression ratio. That is the initial volume before compression upon the final volume after compression, V1 by V2. But we know this thing that compression is adiabatic in nature. So for adiabatic process, P1 V1 to the power gamma equals to P2 to the gamma. This is expression for adiabatic process. So from this formula, V1 by V2 can be P2 by P1 raised to power 1 by gamma. Now in place of this Rk, you can write P2 by P1, that is equals to actually Rp raised to power gamma minus 1 upon gamma, because here it is 1 by gamma. So ultimately you will get this expression. So efficiency in terms of pressure ratio 1 minus 1 by RP raised to the Gauss. Ignition lag in SI engine is actually this is the phase of combustion. In SI engine, when combustion takes place, there are three phases: ignition lag, and then flame propagation, and then afterburn. These are the three phases of combustion in SI engine. So, what is ignition lag? It is the time duration between introduction of spark and flame nucleus formation. Second, it depicts the flame propagation speed. Third, it is the time gap between input of electrical power and formation of a spark in the electrodes of spark plug. None. What will be the correct answer? What is ignition lag? The correct answer is first one. It is the time duration between introduction of a spark and flame nucleus formation. It means what? That between the electrodes of a spark plug, when spark comes, at the same time the flame doesn't develop. It takes some time for development of nucleus of flame around that spark. That time gap is called as ignition lag. Now, which of the following is a phase occurs just after completion of ignition lag in SI engine? I already told in the previous question that just after ignition lag, what comes? These are the four options: after burning, flame propagation, knocking, ignition delay. What is the correct answer? The correct answer is flame propagation. Now, which of the following will directly elevate the knocking tendency in SI engine? Elevate means increasing the knocking tendency in SI engine. Reduction in compression ratio, increment in coolant temperature, increment in spark plug voltage. First option is this. Second, increment in compression ratio, reduction in coolant temperature, increment in spark plug voltage. Third, increment in compression ratio, increment in coolant temperature, increment in charge temperature. Fourth, reduction in lubricant oil temperature, reduction in coolant temperature, increment in charge temperature. Out of these four, what would be the correct answer? The correct answer is increment in compression ratio, increment in coolant temperature, increment in charge temperature. Remember this thing? This is a thumb rule that those factors which will increase the temperature of a SI engine will always increase the knocking tendency. So more the compression ratio is, what is compression? Compression is adiabatic in nature. So adiabatic compression always increases the temperature. So it can increase the knocking tendency. Now increment in coolant temperature. What is the job of coolant? The job of coolant is to cool down the engine. So already if it is hot, if you are increasing temperature of coolant, then it will increase the temperature of engine cylinder. So it will lead to knocking. And increment in charge temperature means the charge is entering inside the cylinder during suction ratio. Already the temperature is high. Then after compression, it will even more high. Okay, so it will also lead to increment in temperature inside the engine cylinder. Therefore, this third option is correct. Remember the thumb rule that for SI engine, the factors which increases the temperature of engine will always increase the knocking tendency. The size of inlet valve is kept more than that of outlet valve in SI engine. Okay, the size, the valve face size. True, false, maybe none. What to the correct answer? The correct answer is true, of course, that always the size of inlet valve is kept bigger than exhaust. Which of the following depicts the volumetric efficiency of an IC? Volumetric efficiency. It is the ratio of specific volume to volume of charge sucked inside the cylinder. Okay, means the volume sucked, that volume, and the charge is going inside the cylinder. The volume of charge is going inside the cylinder. So that ratio, or it's the ratio of charge sucked to the sweat volume of the cylinder, means just reciprocal of first. Okay, it's the power developed to the sweat volume of the cylinder, means the ratio of power developed to the sweat volume of the cylinder. It's the ratio of volume of cylinder to sweat volume, means the entire volume of cylinder divided by the sweat volume. So this is the fourth option. So what would be the correct answer? The correct answer is it's the ratio of charge sucked to the sweat volume of the cylinder. It means what? That when the piston pulls the charge inside, the amount of void it creates, exactly the same amount of charge doesn't go inside. There is some volume left, some vacuum left. Okay, so the amount of charge is sucked inside upon the sweat volume is what called as volumetric efficiency. So ideally it must be 100%. Means the whatever the volume is swept, the same amount of charge must go inside, but practically it doesn't happen. So that ratio is called as sweat volume. Greater the volumetric efficiency is, greater the performance of engine will be. Which of the following depicts the mechanical efficiency of an SI? It's the ratio of brake power of engine to the indicative power. Okay. It's the ratio of indicative power of engine to brake power, reciprocal of this first option. It's the ratio of indicative power of engine to the heat power input. Fourth is, it's the ratio of brake power of engine to the heat power input. What could be the correct answer? Correct answer is, it's the ratio of brake power of engine to the indicative power. Now, what is indicative power? What happens that when the charge burns, after compression, when the charge burns, then heat energy converts into mechanical energy on the piston crown, exactly at the top. So at that time, heat is converting into mechanical work. Okay, so that power, just immediate conversion of heat into work, is called as indicative power. Okay, then the same amount of indicative power doesn't reaches the crankshaft because in between there are so many frictions. The piston rubs inside the cylinder, and then there is connecting rod, and there is gudgeon pin, and then crank pin. So many frictions are there. So whatever indicative power is developed on the piston crown, the same doesn't reaches the crankshaft. So the power which reaches the crankshaft is called as brake power. So brake power upon indicative power is called as mechanical efficiency of the IC engine. Okay. Which of the following depicts the thermal efficiency of an IC? Okay. It's the ratio of brake power of engine to the indicative power. It's the ratio of indicative power of engine to the brake power. It's the ratio of indicative power of engine to the heat power input. It's the ratio of brake power of engine to the heat power. What is the correct answer? Correct answer is, it's the ratio of indicative power of the engine to the heat power input. It means what? I told you what is indicative power. That exactly when heat converts into work on the piston crown. Just immediate conversion. Okay, from heat to work. That is indicative power. So how it is developed? By the help of heat energy by burning of the fuel. Okay, so amount of heat energy which is developed by burning of fuel, exactly the same amount doesn't convert into negative power. Some amount of heat loss also takes place to the outside environment. So entire heat doesn't convert into indicative power. Some lacking is there. So the amount of heat which is converted into indicative power, that ratio indicative power upon the heat power input is called as thermal efficiency. Which of the following depicts the brake thermal efficiency of an IC? Options are same as like that of previous questions. So go through the options. What would be the correct answer? Correct answer is 4. It's the ratio of brake power of engine to the heat power. See, brake power upon heat power means we know this thing that whatever indicative power is developed, when it reaches the crankshaft, over there the amount becomes less. Indicative power is developed, exactly that much amount doesn't reaches the crankshaft. So at the crankshaft it is brake power. So in case you are dividing the brake power with the heat power input, it is called as brake thermal efficiency. The compression ratio of an SI engine is normally kept greater than 4, smaller than 4, smaller than 10, greater than 10. What is the correct answer? Compression ratio. V1 by V2. The volume before compression upon volume after compression. The answer is 10. Less than 10. We don't go beyond compression ratio 10 because if we go beyond 10, it increases the knocking tendency of the SI engine, which is an element of it. What is power by weight ratio of an engine? I think it is simple. The ratio of indicative power and weight of an engine, the ratio of brake power and the weight of an engine, the ratio of heat power input and the weight of the engine, none. What is the correct answer? The correct answer is the ratio of brake power and the weight of an engine. Means, suppose I say some engine is producing 100 kilowatts and its weight is say 10 kg. Okay, so 100 by 10, 10 is the power by weight ratio of the engine. Okay, so simple. The amount of power the engine is developed divided by its own weight is called as power by weight ratio. For same stroke volume and RPM, stroke volume means amount of charge it is. The same stroke volume and RPM, the power by weight ratio of two-stroke engine is more than that of four-stroke. True, false, maybe none. What is the correct answer? Answer is true. The reason being, see what happens that in case you take a two-stroke engine and four-stroke engine, both are running at same RPM and stroke volume is also same. Then two-stroke engine and four-stroke engine, there will not much difference in the weight. And four-stroke engine will have higher weight. Reason being, in two-stroke engine there is no valve system. There are no valves. So some weight is lesser compared to that of four-stroke engine. First of all, second thing, that in two-stroke engine one rotation will give one power stroke, but in four-stroke engine two rotation will give one power stroke. So definitely for two-stroke engine the power by weight ratio is higher compared to that of four-stroke engine. What is scavenging? A process in which the charge of two-stroke engine transfers from crankcase to the cylinder. A process in which charge of a two-stroke engine replaces the burnt gases. A process in which homogeneity of the charge of two-stroke engine is enhanced. A process in which charge of a two-stroke engine is compressed. What is the correct answer? Correct answer is this. The process in which charge of two-stroke engine replaces the burnt gases. What happens? In two-stroke engine, first of all, the charge enters the crankcase and from there it goes inside the cylinder on the piston top. Okay. So when it goes inside the cylinder, then at the same time it replaces the burnt gases, means going inside the cylinder as a fresh charge, as well as the burnt gases are replaced by that incoming of the charge. So that process is what called as scavenge. In two-stroke SI engine of a moped means two-wheeler, while lube oil is mixed with gasoline, while not in four-stroke SI petrol. You would have observed this thing that in two-stroke engines, 2T oil was mixed with the gasoline or petrol. However, it is not required four-stroke engine. What could be the reason? In two-stroke engine, more lubrication is required than four-stroke engine. Is it? In two-stroke moped engine, mixed type lubrication is employed. In two-stroke engine, since the charge first of all enters the crankcase, then to the cylinder. Splash lubrication cannot be used because the lube oil carried with the charge will enter the combustion chamber. This is the third option. Okay. Fourth is 2 and 3 both. What would be the correct answer? The correct answer is 2 and 3 both. What happens in two-stroke engine? The charge goes first of all inside the crankcase and then from the crankcase to the piston top inside the cylinder. So in case we are filling the crankcase with lubricant oil, so what will happen? Mixing with the charge, the oil will go inside the cylinder, and over there, not only the charge will burn, the lube oil will also come and it will burn, and ultimately the entire lube oil will come out from the engine by this burning action. So this will give first of all white smoke. This will increase the pollution level. Okay. Secondly, the efficiency of combustion will reduce. This is the reason that the lube oil is never poured inside the crankcase of a two-stroke engine, but lubrication is required. So for that thing, what is done? In the petrol itself, some lubricant oil is mixed. So when petrol passes through the crankcase and reaches the engine cylinder, so a fog of lubricant is developed. So that is sufficient for developing lubrication effect. Okay. So this is the reason. In case of four-stroke engine, what happens? The lubricant oil is poured inside the crankcase. This is called a splash lubrication. When the crankshaft spins in the lubricant oil, it splashes the lubricant oil all around behind the piston. So by that way, the lubrication is developed in four-stroke engine. But in two-stroke engine, we cannot go like that. So the option 2 and option 3 both are correct. Now, what is the job of piston ring in an engine? To isolate the crankcase lube oil from the region above the piston, to make the piston airtight with the cylinder. It gives opportunity to the piston to expand while the temperature is increased, or of the above. What is the correct answer? The correct answer is all of the above. See, three jobs it does. First thing, that when rings are there applied on the piston, then it develops the types of seal between piston and cylinder, because the piston diameter is somewhat lower than that of cylinder diameter. So there is some gap in between. So that gap is fulfilled by the help of rings. So a sealing is developed. So what happens due to that sealing? The lubricant oil which is below the piston doesn't reaches the cylinder on the piston top. So by this way, both the regions are isolated. And I told you it develops a sealing, so it makes the piston airtight. And one thing, that when the engine becomes hot, then the coefficient of expansion of piston is higher than that of coefficient of expansion of the cylinder. So in case we will keep exactly same diameter of piston and cylinder, then when the temperature will rise, the piston will expand and will stick with the walls of the cylinder and it will become difficult to slide. So these rings are there. So there is some gap between the cylinder and the piston outer surface and cylinder inner surface. So there is an opportunity to expand. So all the above is the correct answer. The job of carburetor is to filter the air content before mixing with the fuel, to mix the air with gasoline with required air fuel ratio, to control the speed of engine, all of the above. What is the job of carburetor? Carburetor is a component of an engine. The answer is all of the above. Actually, it does all these three jobs. First of all, air is to be mixed with the gasoline to make air fuel ratio. So the filtration, in case air contains dust with it, so that dust can go inside and can damage the engine peripherals. So it is clean. It is filtered by the help of this carburetor. Then air fuel ratio. So according to requirement, it develops the mixture. Okay, and the speed control of engine is also executed by the carburetor itself. Inside the carburetor, there is a throttle valve. So by opening and closing of that throttle valve, the engine speed is controlled. So all of the above is the correct answer. Nowadays, which technology is replacing the carburetors? MPFI, FI, direct fuel injection, all of the above. Okay. So nowadays, all these technologies are actually replacing carburetors. Means multi-point fuel injection or fuel injection or direct fuel injection. These technologies are actually replacing the carburetors. In modern cars, no car is there, I think, in which carburetor is used. Carburetors are used nowadays in two-wheelers because they are cheaper. However, these technologies are cutting edge technologies, MPFI, FI, and direct fuel injection. Okay. So these are replacing the carburetors. ABC denotes the idling, cruising, and power range. You know what is idling? Idling means engine is just start. For example, you are starting your bike and just it is still, you are not riding it. At that time, when it is running, means you are not opening the throttle, it's called as idling. Cruising means running with average speed, means for two wheeler or car around 50 kilometer per hour. That is called as cruising range. Okay. Power range means going above 60 kilometer per hour, 70 kilometer per hour, like this. I am taking the example of an automobile. So what is the correct graph expected from an idle carburetor? Means the carburetor develops the air fuel mixture. So according to the condition, means it is idling, the engine is idling or cruising or running with high speed. According to that, the air fuel ratio is prepared by the carburetor. So what is the correct graph which is expected from an ideal carburetor? This is idling range, cruising range, power range. A, B, C. What you see, this is y-axis is of fuel and air ratio and x-axis is of speed. So you can see speed is increasing. ABC stands for idling, cruising, and power range. Means idling speed up to A, then A ends, then this speed range is cruising range, and this C speed range is power range. So out of these four graphs, which could be the correct graph? The answer is the first one. Means in idling range, rich mixture is required. Rich mixture means what? Higher fuel compared to that of air. With respect to requirement, higher fuel is added in the air just when the engine is idling. In cruising, you can see amount of fuel is lessened. More amount of air is required. This is the result that is said that run the vehicle with average speed that is 50 km per hour because in that range, minimum fuel is required for the operation of it. Once we are reaching the power range means higher speed, then again more amount of fuel is required. So this is the correct graph for fuel by air ratio with the speed which is expected from an ideal carburetor. What is the job of choke valve in carburetor? You would have used the choke valve in winters when engine is cold. It widely opens to add more fuel to air to make a rich mixture. Means before entering inside the cylinder, the mixture is made rich by opening it. It is closed to resist the airflow in the venturi, which sucks more liquid fluid in the throat, making the mixture rich. Okay, because carburetor contains a venturi inside it. So in the venturi itself, actually air fuel ratio is developed. It is used to increase the engine speed. When used, it enhances the efficiency of the carburetor. So what is the correct answer? The correct answer is it is closed. Remember this thing. It is not open. When it is used, actually it is closed. So when it is closed, then air, see, when air is coming and you are closing it. So less amount of air will go to the venturi. But vacuum is created by the suction stroke engine. So it will pull more amount of liquid in the throat of venturi. So this will make the mixture rich. And when the mixture is rich, it can burn inside the cylinder easily. And this choke valve is especially used when the temperature is too much low in winters the surrounding temperature is low. In that case, this choke valve is. What is the job of float valve in carburetor? Inside the carburetor, it enhances the liquid fuel to rise through the jets. It floats on the liquid fuel and controls the fuel inlet to float chamber. Okay. It floats on the liquid fuel and used to determine the level of fuel in the float chamber. None. What is the correct answer? The correct answer is this. It floats on liquid fuel and controls the fuel inlet to the fuel chamber. What happens? From the fuel tank, first of all, the fuel enters, the petrol or gasoline enters the float chamber. So that is a temporary storage. So over there is a float wall. So what happens? That when the float chamber is completely filled with petrol, it rises up and closes that opening from where the petrol is coming. Because in case if you will not use it, continuously the gasoline will come, the carburetor will start overflowing. So it checks the amount of fuel entering inside the float. Which of the following is used with main jet or carburetor to keep the air fuel ratio constant with engine speed? Auxiliary jet, float pin, venturi, compensating jet. Means in case we want to keep the air fuel ratio from the start of engine and at highest, in case we want the air fuel ratio to remain constant, then together with main jet, which device is used? What is the correct answer? It is compensating jet. Okay. What happens? That in case we are not using compensating jet and it is a simple carburetor, only one main jet is used, then at the beginning, less fuel will come out from main jet. It will develop a lean mixture. Okay. And when the engine speed is high, at that time, more vacuum is created inside the venturi, the throat of venturi. More amount of fuel is pulled, the air fuel ratio become rich. So from beginning to end, from idling speed to power speed or high speed, we want to keep the air fuel ratio constant, then this compensating jet method is used. MPFI stands for multi-point fuel injection, multi-port fuel injection, multi-point flame initiation, multi-point flame ignition. What is the correct answer? Correct answer is multi-point fuel injection. Okay, and this is alternative of carburetor, I already told. Which of the following is used to measure the indicative power of an engine? Variance line test, dynamometer, Morse test, planimeter. Which one? Correct answer is Morse test. Morse test is a test by the help of which we can measure the indicative power. Which of the following is used to measure the brake power of an engine? Williams line test, dynamometer, Morse test, planimeter. Correct answer is dynamometer. This is used to measure the brake power, the power available at the crankshaft of the engine. Most tests can be performed on single cylinder SI engine, multi cylinder SI engine, both 1 and 2, 4 cylinder SI engine only. Correct answer is only multi cylinder SI engine. It cannot be performed on single cylinder SI engine, and it is not like that it can only be performed on 4 cylinder SI. Okay, so in case it is a multi cylinder SI engine, you can perform most tests to find the indicative. The correct energy balance equation for an IC engine is IP stands for indicative power, BP for brake power, FP for friction power. IP equals to 2 plus FP, P equals to IP plus FP, FP equals to B plus IP, none. What is the correct answer? Correct answer is this. I already told what is indicative power. The conversion of heat into work just on the piston top. Over there, whatever amount of heat is converted into work, that is indicative power. So ultimately, that much power doesn't reaches the crankshaft. Some amount is reduced due to frictional effects. So whatever indicative power is developed on the piston top, some amount of power reaches the crankshaft, that is brake power, and rest of the indicative power is lost in friction power. So this is the correct energy balance formula. Assertion 1. With increasing engine speed, the mechanical efficiency reduces. Okay. Assertion 2. With increasing engine speed, the friction power increases. Out of these four, what is the correct option? Correct answer is this. Assertion 1 is correct, as well as assertion 2 is correct explanation of assertion 1. Means in case engine speed increases, friction increases. So I already told you that IP equals to B plus FP. So in case friction power increases, definitely the BP has to reduce because IP is same. Okay, so with increasing engine speed, the friction power increases, BP reduces. Okay, so this is the reason that the mechanical efficiency reduces. Because what is mechanical efficiency? I already told the brake power upon indicative power. I already told in a previous question. Okay, so up to 30 over here. In next part, I will tell you rest of the questions. Thank you.